Welcome to Sri Chaitanya. This is UMASANKAR, All India IIT Coordinator. Welcome to Season 1 of JEE Max Series 1. As I said earlier, through this season, this is JEE Max, means Main Advanced Extreme series. Through this series, we are concentrating on the concepts, problems, shortcuts, assignments, and tests. So, my friends, already we have completed differential equations up to 3 lessons very successfully, and this is about lesson number 4. And again, I am requesting you, please don't neglect to check the description. There I am providing the very good question papers, sometimes assignments, depends upon the topic that we are dealing. All are very, very important, and we are continuing this series till end of June or first week of July advanced examination. And my friends, by keeping April mains and May mains also into consideration, here we are providing the best information for you. Of course, this is about the differential equations lesson number 4. My friends, here, already we are in differential equations of first order and first degree. There I introduced the methods, how to solve the differential equation of first order and first degree. There we introduced variable separable method and reducible to variable separable, homogeneous and non-homogeneous linear differential equations, and methods of inspection. Today, we are concentrating the homogeneous differential equation. What is the general form of homogeneous differential equation? Because actually, if you have observed the previous videos, there I am giving the concept simultaneously. I am giving some of the best problems. Those problems are recently they have given in they were in JEE February or March session. So thereby you will understand, okay, based on this particular concept, this kind of problems, mixed part type of problem, that kind of things one can understand. So even in your preparation also, simultaneously in your preparation while preparing the board examination, because that too, this is very, very important even for board examination also. So my friends, that's why here the concept that I am covering, and I am covering the questions which are given in the previous or just recently completed JEE mains examinations also. Thereby you will understand the standards of the questions and the importance of this particular topic. Okay, my friends. Now this is about the general form of homogeneous differential equation. Of course, this is first order and first degree, because order is d by dx is there, so order is 1, and the degree of this dy by dx is 1, so this is first order and first degree. This is said to be the homogeneous provided that functions f of x comma y, g of x comma y, both are homogeneous functions of same degree in x and y. That is important. Both are homogeneous functions of same degree in x and y. Actually, here I am introducing, suppose a function f of x comma y is said to be homogeneous of degree n. Do one thing. F of kx comma ky equal to k power n into f of x comma y. If any equation satisfies this condition where k is a real number, non-zero real number, you substitute it, and we can say that it is a homogeneous function of degree n. Degree n. So if I have substituted x with kx and y with ky, both in numerator and denominator, they should get the same degree, thereby degree will get cancelled. So you will get the safest homogeneous differential equation. This is the one of the definitions for checking whether the given equation is homogeneous or not. Okay. If it is the homogeneous differential equation, or if you have identified, so okay, this is the equation which is in homogeneous form, then how to solve? Once after identification, the methodology is for homogeneous differential equation. See here, my x is the independent variable and y is the dependent variable. This is important, because the same thing we can also say dx by dy equal to f of x comma y by g of x comma y. That is also the homogeneous differential equations, provided both f of x comma y, g of x comma y are the homogeneous functions of same degree in x and y. But here we are concentrating dy by dx. As long as we are concentrating dy by dx, means there x is the independent variable and y is the dependent variable. In a dx by dy, y is the independent variable and x is the dependent variable. So please, here don't get any confusion. That is important area in solving differential equations or in calculus part especially. Now, suppose if it is the homogeneous differential equation, first of all, so far we have, in our hand we have what variable separable method is there. That is the only method that so far we have concentrated. For how in one by one we are learning the techniques. Of that, so far we have concentrated the variable separable method. So what I am doing is, I am going to convert this homogeneous differential equation into the known form. Known form means at present I know how to solve the variable separable method only. So my idea is, how can I get this homogeneous differential equation into variable separable? For that, what I am doing is, put y is equal to vx. You consider y equal to vx. This is important. So find dy by dx, that is equal to v plus x into dv by dx. You substitute these things in the given equation, then automatically the equation will be converted into variable separable method. Once if it is in the variable separable method, then separate all x terms to dx and v terms to dv. Thereby you integrate on both sides. You will get the solution, and in the solution you replace your v with y by x. In the final solution or in the general solution, you replace v with y by x. This is the method. So ultimately what I am going to suggest for you is that I am converting the unknown form into the known form. For that, here I am using the transformation y equal to vx. If x is the independent variable. If y is the independent variable, x is equal to vy I can write. X is equal to vy I can write. Or if t is the independent variable, or suppose dy by dt is there, then I can write y equal to vt. So based on the equation, I can use the corresponding transformation. That is important first point. So let's see the method. See, this is the step, as I said earlier. Next, what I am doing, after substitution this, that equation will be convertible into variable separable method, and solving this and replace v with y by x at the end of the general solution. These are the steps. Very simple. Very simple. This is about what a homogeneous differential equation is given for you. Suppose a non-homogeneous differential equation. See, this is the, so in general they are not, so far they have not asked any question in a February session or in March session also, but public examination point of it is important. But try to understand. Here, this is the differential equation. Of course, the function which is in the numerator is not homogeneous, simultaneously in the denominator is not homogeneous. This is not a homogeneous function in x and y. It is not homogeneous function in x and y. Ultimately, this is not the homogeneous differential equation in x and y. So it is what non-homogeneous differential equation in x and y. Here again, two types will exist. Suppose if a1 by a2 equal to b1 is not equal to b1 by b2. This is called type 1 of non-homogeneous. This is called type 1 of non-homogeneous differential equation. So whenever this kind of non-homogeneous differential equation is given for you, what to do? Here also, as I said earlier, what I am doing now, by taking some transformations, I want to convert entire this non-homogeneous differential equation into homogeneous. If it is being reducible to homogeneous, then ball is in my court. I can apply the previous method. Okay, so for that, what I am doing is, here I am using two transformations. One is small x is equal to capital X plus h. Small y is equal to capital Y plus k. I am using these kind of transformations. So from this, you find dy by dx. That is equal to d capital X by d capital Y by d capital X. You will get it. Now what I am doing is, now substitute everything in the given differential equation. That means d capital Y by d capital X is equal to, clear? So this is a into capital X plus small h plus b into capital Y plus small k plus c by A1 into capital X plus small h plus B1 into capital Y plus small k plus C1. So this can be written as what? A capital X plus B capital Y plus AH plus BK plus C by A1 capital X plus B1 capital Y plus A1H plus B1K plus C1. I will get this as what? My capital dy by dx. This becomes the homogeneous only if this term as well as this term, that is AH plus BK plus C equal to 0 and A1H plus B1K plus C1 equal to 0. If these two are equal to 0, then what will happen? That dy by dx, d capital Y by d capital X becomes A capital X plus B capital Y by A1 capital X plus B1 capital Y. This you will get it. This is what? A homogeneous differential equation at which capital X has the independent variable. And solve these two equations, you will get H and K. Solve these two equations, you will get H and K. Leave it. Now it is homogeneous. Now how to solve homogeneous differential equation? There, according to our method, we are taking y equal to Vx. Here, capital Y is equal to capital V capital X. You take it. Again, find d capital Y by d capital X, which is equal to V plus capital X dV by dx. Now substitute as it is, and automatically the homogeneous now will be reducible into variable separable. Solve it, and you will get entire solution in terms of capital X and capital Y and h comma k. Replace, capital X and capital Y. Then replace capital X with what? Small x minus h. Capital Y with what? Small y minus k. And again, what is h and k? After solving these two equations, you will get the values for h and k. No, you substitute those things. Then finally, you will get the solution in terms of small x and small y only. Okay. So this is, when compared with all other methods, a relatively a little bit lengthy process. That's why maybe in the competitive examination, so far they are not asking the questions based on this one. But anyhow, this is very, very important for board examinations. But this is what non-homogeneous differential equations of type 1. When can we say it is type 1? A by A1. That means ratio of the coefficients of x not equal to ratio of the coefficients of y. So see the steps. So whenever I am identifying this is the non-homogeneous, my first concept is small x is equal to capital X plus h, small y is equal to capital Y plus k, find dy by dx, and now substitute everything in the given equation. Automatically you will get the equation of this form. If this becomes homogeneous provided this term as well as this term becomes 0, solve these two equations for h comma k, solve these two for h comma k. Okay, now the equation will be reducible into homogeneous. Then put y equal to Vx. Again, it will be reducible into variable separable, and solve, replace x and y and h comma k with the corresponding values. You will get the answer. Clear? A very simple method. This is what? Non-homogeneous equation of type 1. Now coming to type 2. Type 2. If the ratio of x coefficients is equal to y coefficient, this is called a type 2 non-homogeneous differential equation. Whenever the ratio of x and the ratio of y coefficients are same, you will get a common factor for both the numerator and denominator. You consider that as v. You consider that as v. Obvious. Then find dy by dx and replace this into the given equation. Automatically the equation will be converted into variable separable, and solve it and replace v with the ax plus by in the end of the at the end of the solution. It's very simple. So type 2 is relatively easier than type 1, but this is called what? Non-homogeneous differential equation. So try to understand the difference between type 1 and type 2. Type 2. Okay. Now my friends, see the question, see the problem. Actually, they asked this question in the 16th JEE main March shift 2. This is about what? Homogeneous differential equation. See, if you have observed all the differential equations, Sometimes they are giving in a differential equations chapter in competitive examinations, they are giving two types of questions. Number one, initial value and boundary value problems. That is one type. That means they will give you a differential equations and they will give some conditions. Thereby, one should get a unique answer. That kind of problems are called, that means at x is equal to 0, the value of y is equal to this one. At x is equal to something, then value of y, something like that. That kind of problems are called what? Initial value problems or boundary value problems. Even in our higher classes also, this type of questions you will learn in your engineering subjects. That's a different story, forget about it. And second type of problem is they are asking you to, they are mixed oriented questions, applications of differential equation they are asking. See the question here. It's a beautiful question. Somehow it is a lengthy but easy. Somehow it is a lengthy but easy. See the thing. Let C1 be the curve obtained by the solution of the differential equation. One differential equation is given for you. That is dy by dx is equal to y square minus x square by 2xy. So numerator is of second degree in x and y, and the denominator is also of second degree in x and y. So both numerator and denominators are second degree in x and y, same degree. So it is a homogeneous differential equation. And C2 is another curve. This is about C1 and this is about C2. And both curves are passing through which point? 1, 1. Both are passing through 1, 1. And what they are asking, find the area enclosed with. That means this is one of the application problem with the connection with the differential equation. See the beauty point? So before that, before finding the area, I need to find what is first my C1, what is my first C2. So this is about C1. So now I am finding C1. This is homogeneous equation. So what I am doing is put y is equal to Vx. So dy by dx is equal to V plus x into dv by dx. So V plus x into dv by dx is equal to y square. That is V square x square minus x square by 2. In place of y, if I have written V, 2x square V. So x square gets cancelled. V square minus 1 by 2V. Bring that V that side. So x dv by dx equal to V square minus 1 by 2V minus V. That is V square minus 1 minus 2V square by 2V. That is minus V square minus 1 by 2V. Now what I am doing is, this is 2V by V square plus 1 dV is equal to minus dx by x. Now it is in the form of what? Variable separable. Integrate on both sides. This is what? F dash x by f of x model. So log mod 1 plus V square equal to minus log x, log mod x, plus I can write C or log C. That is my choice. So this is replace V with what? Y by x. So this is log of x square plus y square by x square, because V means y by x. So x square equal to minus log mod x plus C. This is my curve. But this curve passing through what? 1, 1. So that means if x is equal to 1, y equal to 1. So this is what? Log 2 equal to minus log 1 plus C. So my C becomes what? Log 2. Because log 1 is 0. So ultimately what I get? Log of x square plus y square by x square is equal to minus log mod x. And C becomes plus log 2. Okay. And simplify this. This becomes x square plus y square after cancellation of logarithm. This is log a minus log b means log a by b. That is log of 2 by x, that 2 by x. Of course, x not equal to 0, you can cancel it. So I can get x square plus y square is equal to 2x. So after solving the entire equation, the solution of the first differential equation, that is my C1 is x square plus y square minus 2x is equal to 0. This is my C1. Okay. So this is the only thing. It takes time also. But they are asking this question in, they asked this question in 16th March shift 2. See the steps here once again. Yeah, the same things what I have solved now, the same thing they have mentioned it. So put y equal to Vx and substitution, and after substitution and everything. So you got this as your C1 because it is passing through what? 1 comma 1. Similarly, you find C2 and you will get that C2 as what? On the same lines, x square plus y square minus 2y equal to 0. So my friends, both are circles. This is a circle with the center as what? 1 comma 0, and this is a circle with the center as what? 0 comma 1. So one is on x-axis and one is on another axis. So this is the first my curve and another, this is my another curve. So this is the area bounded between these two curves. Now what I'm doing is, now I'm finding this area and I need to find this area. So what I'm doing is, now I'm finding the area like this. So this is the required area. Because this is the area arc, and this is arc. This is a sector area. How to find a sector area? Half r square theta. So find half r square theta or area of the sector, pi square, a square by pi. So you solve this and you find this area, you will get answer that as what? Pi by 2 minus 1. So here what I am going to say is, this is an application of homogeneous differential equation. So here two homogeneous differential equations are given for you. So finding the area is very simple for you. So one thing is here, this area you have to find, and you have to find this area. And by adding these two, you will get area. Or do one thing, this is the area of this circle. From that, you substitute the area of this arc. Then you will get the required areas. There are several methods. Okay, half r square theta is the area of the sector, and area of the circle is pi r square is there. So whatever thing that you are, you depends upon your interest. You can either apply the integration technique, or by common sense itself, you can also solve the problem very neatly. Clear, my friends? So this is about what the question that they asked in JEE main shift to 16th March. Now coming to next example. Yeah, this is 2x plus 3y plus 4 dy equal to. So it appears like what? Dy by dx is equal to, what is dy by dx? X plus 2y plus 3 by 2x plus 3y plus 4. This is my equation. This is a non-homogeneous differential equation, because a1 by a2, that is 1 by 2, and b1 by b2, that is 2 by 3. So a1 by a2 not equal to b1 by b2. So what I'm doing is, put small x is equal to capital X plus h, small y is equal to capital Y plus k. So this is d capital Y by d capital X is equal to, this is capital X plus h plus 2 into capital Y plus k plus 3 by 2 into capital X plus h plus 3 into capital Y plus k plus 4. And this is what? D capital Y by D capital X is equal to, you will get this as what? Capital X plus 2 capital Y plus h plus 2k plus 3 by 2 capital X plus 3 capital Y plus, this is 2h plus 3k plus 4. This is homogeneous provided h plus 2k plus 3 equal to 0 and 2h plus 3k plus 4 equal to 0. First solve this for h and k. How to solve it? Okay, write coefficients 2, 3, 1, 2, 3, 4, 2, 3. H by, this is 8 minus 9 equal to K by, this is 6 minus 4 equal to 1 by 3 minus 4. Therefore, my H is equal to 1. My K equal to, this is minus 2. So, my small x is equal to capital X plus H, capital X plus 1. Small y equal to capital Y minus 2. So, this is my small x and this is my small y. You can get the advantage with the small x and small y later. Now, after substitution of these two things 0 in the given equation, so d capital Y by d capital X becomes now x plus capital 2y by 2 capital X plus 3 capital Y. This is my equation number 2. This is my 2. This is homogeneous. So what I am doing is put y equal to capital Vx. So what I do? D capital Y by d capital X is equal to V plus capital X into dV by dx. Substitute it. So V plus capital X into dV by dx equal to capital X plus 2Vx by 2x plus 3Vx. You cancel x. So 1 plus 2V by 2 plus 3V. So you bring that V that side. So x dV by dx equal to 1 plus 2V by 2 plus 3V minus V. So after simplification, 1 plus 2V minus 2V minus 3V square by 1 plus 3V. After simplification of this, you can get as 1 minus 3V square by 1 plus 3V. Now what I am doing is, this is in variable separable method. Now what I am doing is, now you replace this thing in given equation. I mean separated dv's at one side and dx terms at x. So this I can get it as what? 1 plus 3v dv by 1 minus 3v square equal to, that is dx by x. This is my variable separable. This is my variable separable. Now what I am doing is integrate on both sides. How can we integrate? How can we integrate? So separate these two things. I can do like this. So this becomes integration 1 by 1 minus 3v square dv plus integration 3v dv by 1 minus 3v square. This is equal to integration dx by x. So here what I am doing is, now first one is 1 by a square minus x square format. What is the formula for 1 by a square minus x square? 1 by 2a log mod a plus x by a minus x. So you can apply, well, you take first 3 as common, 1 by 3, that is 1 by root 3 whole square minus v square dv, and you can manage this. This is after differentiation, you can get this as a 6v. So minus 6v plus minus 6v by 1 minus 3v square. Of course, I am multiplying with 1 by 2 dv equal to integration dx by x. So this is 1 by 3 into 1 by a, 1 by 2a. That means 1 by 2 into 1 by root 3 log mod 1 by root 3 minus v by 1 by root 3 plus v, and this is f dash x by f of x half into log mod 1 minus 3v square or v cube is equal to, this is log mod x, plus everything is in logarithm, so I can write conveniently that as my log c. Now the entire, this is the solution. Now what to do? You replace capital V with the capital Y by x. So you will get entire equation in terms of capital X and capital Y. And you replace capital X with what? X minus 1, and capital Y with what? Small y plus 2. And ultimately you will get the solution. This is about what? A non-homogeneous differential equation of type 2 is given for you. This is the methodology. So very neatly, it requires some patience, and neatly you have to draft all the steps very clearly. Otherwise, you will get confusion, and it takes time also for you to solve. That's why, in general, they are not asking this kind of non-homogeneous differential equations in your competitive examinations. But I'm not giving any assurance. They may ask. They may ask. But this is very, very useful for board examination. Now, coming to my friends, this is about another model. See here, my dy by dx is equal to x plus 2y minus 1 by x plus 2y plus 1. Obvious, this is again non-homogeneous differential equation of type 2, because a1 by a2 equal to 1, b1 by b2 is also 1. And if you observe, there is a common factor both in the numerator and denominator. You put that as v, x plus 2y equal to v. Now this becomes 1 plus 2 dy by dx is equal to dv by dx. Now you substitute to dy by dx. That means what? Half into dv by dx minus 1 equal to v minus 1 by v plus 1. So my dv by dx minus 1 equal to 2v minus 1 by v plus 1. So my dv by dx, you take that one that side. So 2v minus 1 by v plus 1 plus 1. These all are the clerical steps only. So 2v minus 1 plus v plus 1 by v plus 1. So you can get 3v by v plus 1. So now what I'm doing is that now it is in the form of variable separable. So separate the terms. So this is v plus 1 by 3v dv, or you keep that 3 that side only, and that is 3 dx. Now what I'm doing is take integration on both sides. This is 1 plus 1 by v dv equal to 3 integration dx. This is what? V plus log v equal to 3x plus c. Because everything is not in terms of logarithm, that's why I have not written c as either log c or something, because every term is different. And you finally replace v with what? X plus 2y, you will get the answer. So this is the method when non-homogeneous equation of type 1 is given for you, and this is about type 2. Hope, my friends, I enjoyed these two problems and these methods. If you like this, you please share and subscribe, and please don't forget to check the description and press the bell icon also. So through these lessons, what I am saying is, here I am giving the concept, and based on that particular concept, what kind of problem that they are asking at present situation, at present scenario in competitive examination, especially JEE main, or sometimes in the JEE advanced. In a recently covered examination, that see the standards of the problem, the mixed oriented problem. The same thing we may expect even for the advanced also. Okay, my friends, we will meet with the differential equation lesson 5 in coming video. Thank you. Wish you all the best.